All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our natural language module. Let's have a look at what we went over tonight. And tonight we're going to be running some code, so let's pick up where we left off. So we were able to do this with a process called tokenization. Tokenization, the task of splitting a sequence of characters into pieces or tokens. In this case, we're splitting a long sequence of text into individual words, and then looking at sequences of those words to get a sense for the structure of natural language. So once we've done a tokenization, up our corpus of engrams, what can we do with that information? Well, one thing we might try is we could build a Markov chain, which we might recall from when we talked about probabilities. Recall that a Markov chain is some sequence of values where we can predict one value based on the values that came before it. And as a result, if we know what all of the common engrams in the English language, what words tend to be associated with other words in sequence, we can use that to predict what word might come next in a sequence of words. And so we could build a Markov chain for language in order to try and generate natural language that follows the same statistical pattern as some input data. So let's take a look at that and build a Markov chain for natural language. And as input, we're going to use the works of William Shakespeare. Let me actually go ahead and show you what we're going to be using as a reference for our corpus. Now you can go ahead and read it if you like. I'm going to go ahead and pull it up now. I'm not going to pause the screen or anything. You can pause the screen on your end, but I'll just pull it up and you can get a quick look at it. I don't know why it's not pulling up. Here it is here. Yeah, so if you want to go ahead and pause your screen and give that a reading over, that's what we're going to be using for our corpus. All right, now moving forward. So this is the code we use here. First, we had to import this Mark Coffee, the pip install. That's what took the video a little longer than usual. We had to import that. Now we're going to read in sample of. Now we're going to read in a sample of text. We're going to read text from file. This is how we're going to do that there. Then we're going to train a Markov model based on that text, and this is how we train the model here. And then we're going to have the Markov chain generate some sentences. We're going to generate a sentence that doesn't appear in the original text but follows the same statistical patterns, generating based on the engrams, trying to predict what word is likely to come next, what we'd expect based on those statistical patterns. And this is how we generate our sentence here. So let's give that a try now before I actually read any further. I might as well just get in to type this out because it's moving kind of slow. See, it's picking up from the last thing. It always moves slow when I'm recording and trying to use my editor at the same time, but whatever. Let's see. And this is my first time running it live, and this is my first time running it, period. So see if it actually goes through and see what we get. And it is an argv or argv2 program. So let's see if it actually goes through. I'm not sure. Oh yeah, that's from the first program it's trying to run that we didn't get the whole code to. So yeah, that doesn't apply to what we're doing right now. So let's see if it picks up our current code and run that and give us what we're looking for. Maybe I should have thought about running it sooner and just running it and then showing you guys the results afterwards. I'll give it a few more seconds before I stop the video and just compile behind the scenes and then record all together at once. Hmm. So the terminal's not responding at all. Yeah, I think I'm going to stop it. I would hate to stop it as soon as it starts compiling, but it doesn't look like it's doing anything right now. All right, let me get and stop this. Oh wait, as soon as I was about to stop it, okay, those from the other codes. Okay, okay. So it looks like we have something back here. Currently, this stick is backed up more than a low pressure toilet at a snail's pace. At times, I can feel us drawing nearer every day. So that's what we got back, and that's pretty funny. Let me actually read what was going on so you can see exactly why we got that back. Why it seems so jumbled. So what we're gonna get are 5 new sentences. If the corpus was long enough, we would have got 5 new sentences. But since our corpus was kind of short, we only got back this one here. And so what we're gonna get back is 5 new sentences, where these sentences are not necessarily sentences from the original input text themselves, but just follow the same statistical pattern. It's predicting what word is likely to come next based on the input data that we've seen and the types of words that tend to appear in the sequence there too. Of course, so far there is no guarantee that the sentences generated actually mean anything, as you can see, or make any sense, as you can see. They just happen to follow the statistical pattern that our computer is already aware of. We'll return to this issue of how to generate text in a more accurate and meaningful way a little bit later. So yeah, it looks like our code is working. It did take in our short corpus, and it did spit out a sentence for us. Even though if the corpus was longer, we would have got 5 sentences like we were supposed to. But at least we know it's working. So with a longer text input, we would have got back our complete 5 sentences. But we got this back instead. Currently, this thick is backed up more than a low pressure toilet at a snail's pace. At times, I can feel us drawing near every day. Like I said, it didn't make any sense, but we'll focus on that problem a little bit later on. But yeah, of course, I will keep you posted on the progress. But for now, this is the Python Poppy. You guys stay Gucci.